today I'll speak about Eötvös experiment. And probably before I start, it needs to be mentioned that this experiment not a few years experiment of Florian Eötvös, it's rather his life work. And in this case, I will speak just a little bit about his life, some student research, just a few minutes, and everything else will be fully concentrated on his study in gravitation and magnetism, actually from which exists this famous experiment. So really today he's famous for his gravitational study, surface tension, which we done in the student's time, and the construction of the torsion pendulum, one version of which today holds his name. So in this picture you simply see his later invention with which he demonstrates Eötvös effect. We will speak later, and just simply sum his death.
Question, how do you pronounce his name? Around, that's easy, but the last part?
There is a few different possibilities to mention. Somehow name it like Eötvös, another one Eötvös, Eötvös.
Okay,
So probably Hungarians can tell us correctly who is one.
And this very, very long something that begins with...
Yeah, actually this is interesting fact that a lot of students that signed for his courses simply signed because it was born and have such funny name. So, beginning about his life, Lord Eötvös was born in a family of politics man and writer Joseph Eötvös, not the last person in Hungarian cabinet of ministers. That's actually why he got private tutor and later studied in Paris. Of course, he went to study by his father and study law, but law study failed to satisfy Eötvös, and he always find time to participate in some natural science courses. This actually, I will jump between two slides because father of Eötvös played an important part in his life. Just for example, getting his father concerned. This may be here. Actually, Eötvös was very want to visit the science courses and write to his father that he was born with ambitions and to duty only as a nation, but toward to the whole humanity. This simply show the ambitions of Eötvös, how he thinks the science will influence in his life. So, getting his father permission, he began to study in the Heidelberg, where he became a pupil of famous Bunsen, Helmholtz. Later on, he spent 6 months in University of Königsberg, but find this lecture too abstract and returning to the Heidelberg. So I'll return this here.
Excuse me, can you tell what is the city of Königsberg now?
Probably no. It's written like Hellenberg, something like that.
Helen, not Königsberg. Hellenberg.
Yeah.
Well, I thought you said
Probably
Königsberg.
have some probably this is under name. So thirsty for adventure, Eötvös also want to participate in researchers which predict him to actually visit different places on the earth, and his father refused this. How he said he always pay money for his study, but it's too much for their family, and he simply asked Eötvös to stop this idea and concentrate on his study to finish his course with his name. Perfect. After his father's death, actually the most truest friend, not also father, he applied to the post of lecturer at the Faculty of Theoretical Physics, the past university, which right now bore his name from 1850s. With the recent years, Eötvös trying to avoid some prestigious appointment, but to be honest, it is difficult to even count how much of them he received. So always it was like in his laboratory or home or something like that. Even on his dying bed in 1980, he still continued working. Probably also want to mention about Eötvös like sportsman and photographer, because as he loved to say during his friends, he was more proud about his climbing abilities, even the invention of the torsion balance. On this picture we simply see the building from journey of Eötvös starts, not only by making measurement, but simply resting. So here is like Misumira, scanner in Alps, his first measurement in Sun Hill, frozen lake of Balaton, and some instrument transport on elephant. So it was like a scientist. Eötvös was not interested in research which will give him immediate public acclaim. He was interested in the how he said, in the powers of nature. This actually two scientists take it with him. He think he was true natural scientist and find pleasure in such researches. So, still being a student, he began work on the circuit tension, where he invented his rule, which right now bears his name. Surface tension is elastic tendency of liquid, which makes them quietly surfaces possible. So, first assumption of Eötvös was that this dependence from temperature and surface tensions is actually linear. And it can be seen from this graph of surface tension of benzenes. It's mostly linear. Continued work is in this field. The research probably, I will put this round just simply to make it work. Unfortunately, it doesn't work. Oh, no, it's work. Just to make some illustration to my speech. Continued work on the surface tangent, he invents this actually law to solve that this dependence is not actually linear. He showed that the surface tangent can be really predicted if we're pretty sure about the molar volume and critical temperature. And this is value which gets Eötvös constant value. It was simply his student work, but already give a lot of satisfaction to us. Leaving this research, which was actually from 1876 to 1886, he fully left this research and concentrated on the magnetism and gravity. But it doesn't mention that. It doesn't mean that nobody continued to work in this field, and it's actually evolved with few changes. Like in 1893, William Ramsay and Shields showed that improved version, considering that this line, which was shown previously, supposed to pass temperature of 6 Kelvin before critical point, because as was shown by Eötvös, in these critical points, surface tension is actually equal to 0. The further researchers of Jones, Leonard, Jones, and Corner, and their statistical derivation of this formula show really good variant of this formula with using Avogadro constant, and this new Eötvös constant K prime was shown that is really close to the Boltzmann constant. So finishing this study, the surface tension, he was fully concentrated on the gravity and magnetism. There is two aspects which was based on all research of Eötvös. This is the strict physical theoretical aspect of all of this process, and the construction of an unbelievably sensitive instrument, named right now Eötvös torsion or simply torsion balance. And this balance actually evolved during his life and his researches. About the torsion balance. It's actually one of the first devices which allows Eötvös to measure, perform measurement in gravitational magnetism, and actually which fell in the famous experiment in which he showed as precisely at the time as possible the equivalence of gravitational mass and inertial mass. Probably I'll change and return next here. Just to show these pictures. Development of torsion balance begins from the curvature variometer. It was the simply horizontal beam hung up with the torsion, two masses on the each sides. I will speak about this experiment later and actually explain why so precisely. Further improvements make this another mass connected on the string of its own, which evolved into horizontal variometer, to the making measurement on Balaton's lake. He also improved this one, if you can see here. 1902 was evolved into double balance, which actually horizontal variometer, but with this horizontal beam in opposite sides. So during one measurement he can compare the results from different, and simply construct a double small balance later for easiest field measurement. So I see from this picture, it's not like Eötvös construct some devices, make measurement and confirm. It really was work of his life, and always with the new device he performed all measurement and increased the quality of the previous results. So turn here. Just one would try to mention that curvature variometer measure the curvature of a potential surface of the Earth from its deviation from the spherical shape, and so actually direction in which this curvature was made. And horizontal variometer, which was made just a few years later, gives the gradient of the gravity, which defines change of gravity over the horizontal distance of 1 centimeter. Actually, first measurement of distortion balance was performed in 1891 in Sag Hill, and the general idea of this measurement was simply to check measurement of another geologist, Australian geologist Sterling, and he simply confirmed that there was some mistake in this measurement. In 1801, the measurement was performed on the frozen lake, Balaton. And from these results, he established the fact that, during this horizontal line, the light was tectonic line. The first idea wasn't far away from geologist researchers, but actually Eötvös was always interested in possible use of this device in geology. That's actually why it's involving here. Gravity compensator is actually another device, strictly speaking, curvature variometer, but provided with deflection, just sector shaped deflectors here and here. So when it was in state of equilibrium, they don't have any influence on the device, but And also, if you put it in the vertical position, it also don't have any effect. But if deflectors return it in the horizontal position, they improve the stability of whole devices. So if another object will be close to the gravity compensator, it will influence on device, and the changing of these sector-shaped deflectors can increase the performance. Actually, with this instrument, Eötvös could register changes in water level in the distance of 100 meters. Also, studying gravitation, Eötvös was interesting simply to check the gravitational constant. How he do this? He simply use some object oscillating between two walls, measure how they will oscillate parallel to the walls and perpendicular to them. Knowing exactly the mass of these walls, he can actually calculate the gravitational constant. Speaking about this comparison of gravitational and inertial mass. Mass, it's a property of physical body. On one hand, simply to show the influence of the gravity, and another one is how strong it can resist to some acceleration. And that was interesting into comparison of these two masses. So actually, he thinks that the inertial mass he simply can calculate from Newton's law of acceleration, and the gravitational mass of body determines from the gravitational attraction. Probably I'll return this. What did this mean is actually how Eötvös named his paper, because it's really true according to his paper, which means that art's long forever and life is short. He always loved to say that he aware about human limitation and leave further improvement and researches to the next generation. And he only tried to make this research as clear as possible and show this one. And about this data sheet, probably I will mention later, because it's really related to the Dick's criticism. So really fast, I go to the original experiment. Here we have that horizontal beam hung up on the torsion. Torsion was prepared very well. Just during a few years, was simply hung up with some masses just to avoid any possible influence in the development. So the main idea was that hung it up and putting in the side of this device. There is just few forces acting on this device. There's just on these two masses: gravity forces and the acceleration of the Earth, and actually string tension. The main idea was, if these two masses is different, there is state of equilibrium in horizontal, in vertical position, but in horizontal it can still rotate. So any small changes in these two masses is influencing the rotation. To see it more clear, I'll open this one. So divided these gravitational forces and acceleration into the horizontal and vertical plane. Just writing these two formulas in one and another plane, where we have torsion, putting one into another and assuming that the gravitational constant is much bigger than this part of the acceleration force. As was getting such relation, from which was really clear shown that any difference of masses will perform some torsion. In making his first research in 88, apartment, and looked like getting permission. He decided to make it measurement in the field, making this measurement in Sac Hill. He prepared a new paper, which was actually just 3 sheets of paper. He showed this in a conference in Paris. A lot of people was taken by doubt quality and whole experiments at all. That's why this huge measurement on the Balaton lake was performed, and why he chose this one territory, because he want to avoid any possibilities which will influence on the measurements, even the geological masses that we actually took from the mine.
Okay, may I ask you here, because I am sort of lost here. This is on the left-hand side, you have a picture of this pendulum, of this torsion pendulum,
yes.
right? On the left you have a mass, and on the right you have a mass,
yes.
right? Mass A and mass B on the right, okay? So you have gravitational forces pointing down.
Masses are
Yes.
different. Masses are different.
Masses are different. Then you have the centrifugal forces acting horizontally,
Yes.
right?
Yes.
What is this force acting up?
Force, this is also acceleration, but the horizontal part, if you divide this, it's not actually horizontal, it's just part of this rotational power.
You mean because we are on the sphere rotating?
Yes, exactly. There is
Okay,
actually...
so the centrifugal force has 2 components.
Yes.
Yeah.
Yes.
Vertical and horizontal.
So if it will be in state of equilibrium in one position, it doesn't mean it will be in a horizontal one. Only position way to rotate for this device is horizontal position. That's actually why we have a mirror between them, and smallest changes of this rotation will light into the detector and show these changes.
Okay, and this motion, well, these forces are not in equilibrium, that's what you are saying, and that is because the
this is
pendulum...
assumption. They will be in equilibrium if they are the same. This was main assumption. And it was experiment of 1889. Further researches was performed exclusively by making it fully symmetry and put different device, different materials into device to check if there is some relation to the material of the gravitational and acceleration force. So actually, this was the very first experiment which we will.
No, I'm just thinking how this experiment was performed. You have these 2 masses forming this torsion pendulum, and you look at what? At oscillations.
You put it in fully equilibrium position.
Okay.
And then simply performing measurement during maybe hours, maybe day, if it will rotate. It will rotate only in one cases if 2 masses different.
Okay.
The
So
most
if this big T is different than 0,
Okay,
Yes.
and this
Yes.
big T comes from this
From
this
this
thread,
Yes.
right?
from this
From the string.
from the bracket on the
Come on. What is T? The T is distortion, right?
Yes,
When it
exactly.
rotates, that they are
exactly. So
okay.
it's supposed to be 0 to show that mass is the same.
Okay. And this is on the scale of
Mass of force.
Forces, but from this variant is shown in the perspective of the masses.
So,
okay, whenever you have mg, this is gravitational force,
Yeah.
right?
Yes.
And whenever you have
It's
ma,
inertial.
that this is inertial.
He made this,
because there are 2 different, a priori, the centrifugal force is proportional, of course, to the inertial mass, because this just has nothing, it is not the force, it is just the real representation of the acceleration.
Yes.
On the other hand, you have this, so there are 2 forces which a priori could be different. However, to say what is different, what is the ratio between mi and mg for one body is meaningless, because it depends upon the units you choose. However, the point would be that he puts different, for instance, lead and wood, and the idea is to see whether this ratio is different for different materials, and that's all.
And coming back to the experiment, he waited for how long in order to see the rotation?
From 1806 to 1809, he performed 4,000 hours of measurement. So, yeah, this is measurement from
Well, one can also see that the beauty is that because the square bracket must be 0, you can increase the prefactor by increasing mass or length, and then you increase sensitivity.
So yeah, actually, the further improvements of this measurement was different type of sample in 1889, building of this horizontal variometer, and later, this 4,000 hours measurement performed in these years was not published by Eötvös himself, but his teammates Packard and Piquet, because Eötvös died before it in 1990. Further measurement was performed by them. Also, looking more precisely at this experiment, in 1889, showing this proportionality of inertial gravitational mass, the quality was such level. On the previous slide was shown that this number exactly means if you have material, very small, tiny 1 gram of materials, stretch it, set it 5 times during the Earth, cut 1 millimeter, so this is actually part which device can detect. And even further improvements to the 1 to the billion, the original experiment, how said was Hungarian Academy in 1890, it's so sensitive method as possible as it can be shown at that time. Also, in 1806 and 1809, it was performed, make this results shown in a geodesic conference in London. Why it's so important? Also, showing all of these experiments, the society was so impressed that they asked Hungarian government to put more grants to these gravitational researchers and ask Eötvös to visit a lot of the countries simply to perform such measurements. Also, what I'm speaking about, the most famous and most known paper was published in 1822 by Packard and Piquet, and on this paper was cited by Einstein in his relativity theory. During this measurement was a lot of related study. He performed in 1908 some measurement in Black Sea. The idea of this measurement was performed because he was studying the results of German team from Institute of Geodesy in Podstaw, and he noticed that their result was different when the ship was moving to the eastward and westward. He made assumption that it's due to the Earth's rotation, the position, and probably I will mention about this a little bit later. Continue these researches in 1830, the students of Eötvös, Janus Renera, and his quality actually was speaking about was between 2 and 5 billion. This one. And later on, Robert Dix performed a run of all of this experiment and get the accuracy 1 to the 100 billion. And this accuracy gives opportunity to check correspondence of these two masses, not in order to the Earth, but in order to the Sun. The main idea was that Earth rotated 24 hours, and any perturbation during these 24 hours can be reduced due to the Earth's rotation. And actually, to be honest, it was also performed this measurement, but never publicated this because don't wasn't satisfied in the results of what he determined results and the quality of this experiment. Also, recent researchers in this gravitation checking the results of Eötvös by decay, he finds some errors in this measurement, and this influence into whole story, which is named Dick's criticism, because he performed a lot of the papers that simply critiques all of Eötvös' experiment. First of all, he was suspicious about the perturbation motion created by the temperature. More recent experiments performed also to check Eötvös' experiments show that he was really precisely good in this aspect. For example, in this double torsion balance was 3 thermometers on each masses and on the torsion wire. So this was not like horizontal beam on the string. It also was coated in triple copper shell to hide everything. And the measurements always was performed in closet room or some, for example, in this malaton measurement in tent, double tent with some cedar wood between them, always trying to make some symmetries and avoid any possible perturbation. And another most criticism by Dix was concerned that even person who make measurements can influence this device, and it was really so. But also it was very concerned about this source of mistake, waiting, dumping of the device for a few times. The observer simply come, turn it running, and make a reading, and just simply go away and measure what the measurement was done. And about the sheet of the paper was previously. This was another problem why Dickens so criticized this experiment, because it is difficult to make this comparison and make statistical evaluation of imperial data original by Eötvös. He simply made this known such papers as still on the university. There is all this information, but probably without Eötvös nobody can say what is right in there and to make the same statistical evaluation. This also influenced into another story that Picker making experiment, the same experiment but actually in another room. Here I have a picture actually where measurement was done. Even this was checked and it was not really symmetry. Rainier was in another room. So making this measurement, Rainier tried to avoid of influence of environment changes, but by interpolation in time. This interpolation, not getting the number in this, during this interpolation will be not statistically independent, but Rainier treated them like they were. And this case to arise in the statistical errors just 3 times more. Taking this into account, his results was very suspiciously lie near to the 0. In the same time, Eötvös results have some correlation. And trying to explain this, a lot of measurements was done during 40s by Decay and more recent scientists. And really interesting in this fact that more recent scientists don't see this effect what was found by Dickens. Of course, the experiment somehow performed in another way than the original one, and can be some fact present that hide this difference inside. But speaking about this rerunning, it was checked so precisely that even territory was the measurement with this perform it, just the sack heel on the one side and the right hand on another where the university was built. And there is few theory that can take into account just 50 meters of the room and can explain why this changes is present. It's actually, I use this picture. It's still performant right now. I'm trying to explain why it is present. And in addition, to show how precise it was with his measurement, I add this chemical reaction, which wasn't published in any of his paper, but getting from the correspondence between Eötvös, Pekka, and Vitalii. What is showing here that they trying to make the same measurement performed before and after reaction. Showing actually here. So of course the center of mass will be not exactly in the same place of initial reactants and the results. And it will influence to some gravitational effects. But during to their correspondence, they know about this effect. Make such changes, there is nothing was occurring. So it was so precise that even chemical reaction was checked. About the recent measurement, I want to mention about Eötvös group. This is really a group of 24th century. It makes it rerunning of all of original experiments, even the square Newton law. This is actually what is writing here, the point that this team put in to themselves. Actually, the goals that they put for themselves. But I want to mention most of all about one, which is actually checking this equivalence principle and Newton's square law. In this picture, we see this 21st century balance, which is still have the same idea like Eötvös balance, but constructed with two or three, or right now even more circle plane, which have a hole inside to. It's not like right now like pans or materials put inside. It's a simply plane with a lot of the holes of. Idea actually the same. If any object will be influenced, it also will be retained, and string still presents in such a long term, passing so many years, string still presents to make such measurements. Actually, Eötvös effect. Checking results of this German group, he noticed that their measurement was different when they was moving eastward and westward. For this purposes, he derived a formula to correct this motion. Here we see this is actually rate of the rotation of the Earth, the velocity of this object in east-west direction, and the velocity of the north-south direction, and also radius of the Earth. The Eötvös effect is mostly named by the Fish coefficient, and what we see here is simply latitude in which performed the measurement. The first part of this equation is named, actually it was effect, and it's much more than the second one. And the second one is actually not related to the Earth's rotation, and also to this direction is simply to correct the motion of this object.
So is it the Coriolis force?
Sorry?
Is it this first term, the Coriolis force, Coriolis acceleration, or is it something else?
From actually this force rise another rule which saying that the closer to equator the stronger is effect. So making this correlation, he take into account position on the Earth's latitude, longitude, and also take into account that normal force don't act exactly in the same way like a gravity force, and it performed some centripetal force, additional one. So if you measure the motion like longitudinal by moving in the circle, you can use the previous formula to correct this one. And moving closer to equator, this effect will be stronger. This is actually the results of checking by him these results.
Okay, but it does depend upon the omega, on the rate of Earth's rotation.
Yes,
That's 1 over 24 hours.
Yes.
Omega.
Even objects that still stay still on the Earth have additional energy.
No, because you had U over there, which was the component of velocity, wasn't it?
Yeah, this is component of velocity. It means adding the velocity of the Earth plus the object which rotated during the Earth.
Yes, so I guess that this is Coriolis force, isn't it? So Coriolis acceleration. I think so. Even this two is correct.
And show this
Proportional to the velocity.
And to show this effect, he also constructed another device shown here. It's simply have the same idea. It's right now it's two masses already connected to this beam. The plane rotates evenly, and when it's moving to the east, it begins heavier, and to the west, it begins lighter. So just simply device to count. Don't want to collide. Almost 50 devices was constructed by Eötvös for different purposes. So he really looked on the some physical aspect and constructed different devices. Performing all of these measurements in gravity, he also noted that he can perform some measurements in magnetism. The new devices which he constructed, he simply replaced one of the masses by magnetic needle, which showed the direction of the Earth's magnetic field. And moving this device close to the some ancient bricks, or just simply another very old object, he can notice their old magnetic inclination. And during this research performed by trial during the walls, also this measurement was performed simply to build this old magnetic inclination in the past. And probably to summarize everything, today's Eötvös, by Eötvös borrow his name, the university in Budapest, the crater of the moon. He has a unit named by Eötvös, and even peak in Italy, almost 3,000 meters, where he was climbed. During his life, he was still named by Eötvös.